Okay, we are going to talk about probability and multiplication rule in 12.5 here. So, a few different vocab words that come up here. We have compound event or composite events. Usually, I've heard compound event consists of two or more simple events. Now, we've kind of done some stuff with this already. Independent events are two or more events in which the outcome of one event does not affect the outcome of the other events. Now, these are kind of interesting. We'll get into those a little bit here, but that's the idea of an independent event. Suppose a coin is tossed and a spinner shown is spun. The sample space for this experiment would include a heads and a one, a heads and a two, a heads and a three, a tails and a one, a tails and a two, and a tails and a three. Those are the different things that can happen. Using the sample space, the probability of, sorry, I'm moving down here, the probability of the coin landing on heads and the spinner on a two, probability of H and two is 1 out of 6. Because if you come in here, you're looking for a heads and two, you have 1 out of 6 total things that are happening. Notice that the same probability can be found by multiplying the probability. So probability of heads is a 1/2, 1 out of 2. Probability of a two is a 1 out of 3 because of the spinner. And if you do 1/2 times 1/3, you get 1/6. So just recognizing that these two are the same thing. The reason that's important because it's not always only 6 options that you get to list there, and you don't always want to have to list all of them. Okay, so the first, this example illustrates the multiplication rule, first of two multiplication rules for probability. So if two events A and B are independent, so they don't cause one or the other to happen, then the probability of A and B is just the probability of A times the probability of B. Okay, so that's going to be something that we focus on quite a bit, and it could be then times the probability of C if needed. So we kind of just work our way through there. Consider choosing objects from a group of objects. If you replace the object each time, choosing additional objects are independent events. Okay, so think about that because this is something that throws people off. If you replace the object each time, then they still are independent events there. Okay. Okay. If we move on, we have a weather app that's making there's a 20% chance of rain on Tuesday and a 50% chance of rain on Wednesday. What is the probability that it will rain on both Tuesday and Wednesday? So in that case, you would do your 20%, that's your first option, times your 50% chance of rain. That's your second option. And that's going to give you a 0.10 answer or a 10% chance, or you can write it as 1/10. So if it's asking for different answers, 0.10, 10%, or 1/10, any of those three are fine. Okay, Tuesday and Wednesday in that case. That's how you find that. Okay, so probability of dependent events. So dependent events are two or more events in which the outcome of one affects the outcome of the other. Suppose a marble is chosen from the bag and placed on the table, then another marble is chosen from the bag. The sample space for this experiment is only these four, but that depends on like what is chosen and what the probabilities are. So when choosing the first marble, there are 7 possible outcomes. The probability of choosing a red marble in the first draw is 5 because there's 5 red marbles out of 7 total. Okay, because that marble is not returned to the bag, so we assume that this red marble is now gone. There are only 6 possible outcomes for the second drawing. If a red marble has already been chosen, the probability of choosing a red marble in the second draw is 4 out of 6. So there's 4 red marbles out of 6 total at that case. So the second of the multiplication rules of probability addresses the probability of two dependent events. And so what you do is the probability of A and B is the probability of A times the probability of B given A. So this is kind of a new notation that is here, and there's a little note about it. I don't know why it keeps doing that. On the side, the notation of probability of B/A is read the probability that event B occurs given that event A has already occurred. So what we're going to do here is assume that event A happened. So we got a red marble, then we're going to find the probability of B assuming that already happened. So that one was gone, which is why we got the 4 out of 6 from that. Okay. Okay, so determine whether the events are independent or dependent here, given this listing. So if we, of the $100 that Ray has to spend, she wants to spend 59 on a blouse and 44 on some jeans. So this one gets a lot of people, but the answer is that they're dependent, okay? Because based on how much she spends on the blouse will depend on how much she can spend on the jeans and vice versa. So they're dependent on each other since she only has $100 to spend. Okay, Ray asked each of the 3 store associates which handbag they prefer. So she's asking 3 different people what they prefer, and those are independent of each other because everybody has their own opinion there. And then lastly, Ray purchases a handbag and a belt. So just purchasing a handbag and purchasing a belt, there's no um, money amount on it or anything like that. Those are independent of each other. Okay. On a math test, 5 out of 20 students got all the questions correct. If 3 students are chosen at random without replacement, what is the probability that all 3 got all the questions correct on the test? So what we're doing here is we're saying that for the first person to get them all correct, 5 out of the 20 students have them all correct. Now we take that person without replacement and put them to the side. So now we're choosing another student, but we now only have 19 students we're choosing from. One of the correct ones was chosen, so we only have 4 that got all of the questions correct. And then we have a third 3 students, right? Yep, a third student, so 18 students and 3 of them. And if we multiply that out, we're going to get 1 out of 114, which is about 0.9%. So 0.009, I could do it right. Okay, so any of those would be correct there. Okay, so that's what we have for 12.5.